Assalamualaikum and hi, we are from group 6 and we will present about Helmholtz Free Energy. Hi, my name is Nurul Afika binti Atan. My matrix number is 195990. So I will present about the Helmholtz Free Energy
Hello,
definition
my
and the
name is
function.
Olga Valentine Sebastian and my metric number is 195907. And for this presentation, I will explain on the derivation of Helmholtz free energy.
Hi, my name is Nozafira binti Zulkifli. My matric number 196386. I will present about the application of Helmholtz free energy.
Hi, my name is Hanis Nabila binti Muhammad Isnizar, metric number 19329, and I'll present on the simple example question on Helmholtz free energy.
And I'm Nurhanis Peti Muhammad Saleh. My metric number is 199623, and I will present on the difference between Helmholtz energy and Gibbs energy. So without wasting time, let's start our presentation with Afika.
So what is Helmholtz free energy? Helmholtz free energy is a thermodynamic potential that measures work of a closed system at constant temperature. It is developed by Hermann von Helmholtz, a German physicist, and denoted by a letter A that refers work in German, or some use letter F. The equation is A equals to U minus Ts, where U is the internal energy, T is the temperature, and S is the entropy. The negative of difference in Helmholtz energy is equal to the maximum amount of work of a system at constant volume. If the volume is not constant, the work will perform as boundary work, but commonly used in a system at constant volume since there is no work performed. Therefore, the drop in Helmholtz energy is equal to the maximum work on the system. A system at constant temperature and volume, the Helmholtz energy is minimized at equilibrium. Next is Helmholtz function. In equation of states, the sum of ideal gas and residual terms in pure fluid with high accuracy, for example in industrial refrigerants, and another one in autoencoder to find the sum of code cost and reconstructed code. This will explain more in application. So that's all from me. Thank you.
Now, I will continue on the derivation of the Helmholtz free energy. The first law of thermodynamics stated that energy change of an isolated system during any physical process is equal to zero. And by looking into the equation, change in internal energy is equal to the change in heat plus with the change in work, where the change in heat is less than or equals to the product of temperature and change in entropy, and the change in work is equal to the negative pressure multiplied with the change in volume. And by substituting these two equations into equation number 1, we will get that change in internal energy is less than or equals to the product of temperature and the change in entropy minus the product of pressure and change in volume. However, in Helmholtz free energy, volume is constant, so PdV can be cancelled out and we will get 0. Now, the change in internal energy is less than or equals to the product of temperature and change in entropy minus 0. By rearranging the previous equations, we will now get that the change in internal energy minus the product of temperature and change in entropy is less than or equal to 0, and dTs is equal to the product of temperature and change in entropy plus the product of entropy and change in temperature. So substitute dTs into the previous equations and we will get the change in internal energy minus the product of temperature and change in entropy plus the product of entropy with change in temperature is less than or equal to 0. Also, in Helmholtz free energy, temperature remains constant. So we can cancel out SdT and change in internal energy minus the product of temperature and change in entropy is less than or equal to 0. Factorize that out, and now we will get change in internal energy minus the product of temperature and entropy is less than or equal to 0. And internal energy minus the product of temperature and entropy is equals to A, where A is the Helmholtz free energy. And it is stated that value of A should stay the same in a reversible process and decrease in an irreversible process at constant volume and temperature. That's all from me. Thank you.
Okay, now I want to talk about the application of the Helmholtz free energy. The first one is explosive. An explosive, a reactive substance that contains a great amount of potential energy that can produce an explosion if released suddenly. Usually, is accompanied by the production of light, heat, sound, and pressure. An explosive charge is a major quantity of explosive material which may either be composed slowly of one ingredient or be a mixture containing at least two substances. In previous study, the closed form solution of the Helmholtz free energy equation is performed using the simplifying assumption that the system is thermal equilibrium and that the reaction is taking place at a constant volume. In other words, the Helmholtz free energy is a minimum at thermal equilibrium. In explosive research, Helmholtz energy is often used, since explosive reaction by their neutral induced pressure change. It's also frequently used to define the fundamental equation of the state of pure substance. Next, we move to the application to training auto and the code. Auto-encode, this type of artificial neural network used to learn efficient data coding in an unsupervised manner. The aim of an auto-encode is the learn of presentation for a set of data, typically of dimensional reduction, by training the network to ignore this signal noise. Along the reduction side, the reconstruction side is learned, where the auto and the codes try to generate from the reduced encoding to a presentation as close as possible to the original input. Han is named. Several variants exist to be a basic model with the aim of forcing the learned presentation of the input to assume useful property. Some research derive an objective production of training auto and the code based on the minimum description length principle. The description length of input vector use a particular code in the sum of the code cost and reconstruction cost. It's defined this to be an energy of the code for the reason that will become clear later. Give an input vector is define the energy of a code to be the sum of code cost and the reconstruction cost, which the cost has exactly the form of Helmholtz free energy. Okay, go to the next slide.
Thank you, Zafira, for the wonderful presentation earlier. So now we'll proceed with the example question of Helmholtz free energy. First, let's read through the question. It says here that what is the Helmholtz free energy of rigid polyvinyl chloride at 123.8 degree Fahrenheit and at 20,000 psia? So, given temperature and given pressure. Also, it says here that given entropy of the rigid polyvinyl chloride is 0.045 joule per Kelvin. Okay, so now for the solution. From the derived equation earlier, we have the equation of A equal to U minus Ts. A is the Helmholtz free energy that we will be looking for. T is the temperature given, which is 123.8 degree Fahrenheit, and S is the given entropy, which is a value of 0.045 joule per Kelvin. Problem is that we are not given with the value of U. So what we will do is that we will differentiate the whole equation, in which it will give us with the equation of the A equal to du minus TdS minus S dt. Note that du equal to TdS minus PdV. So we will substitute the TdS minus PdV into du from the previous equation, and it will give us with the equation of dA equal to TdS minus PdV minus TdS minus SdT. TdS minus TdS can be cancelled off, and it will give us with the equation of dA equal to minus PdV minus SdT. Okay, so now let's read through the question again carefully. It says here that the polyvinyl chloride polymer is rigid, hence dV is equal to 0. So from the previous equation of dA equal to minus PdV minus SdT, minus PdV can be cancelled off since dV is equal to 0, and it will give us with the equation of dA equal to minus SdT. Now, we can already substitute the value of S into the equation as well as the value of T into the equation, and it will give us with the dA equal to minus 0.045 joule per Kelvin multiplied with 324.15 Kelvin, and the final answer will give us with A equal to minus 14.58 joule. And that's all for the very simple example question of Helmholtz free energy from me, and I'll pass on the presentation to the next presenter. Thank you.
Thank you for the amazing explanation for example question, Hanis Nabila. So we will go to the last part of this presentation, which is the difference between Helmholtz free energy and Gibbs free energy. As we all know, there are four major thermodynamic potential that are used in the thermodynamics of chemical reaction. There are internal energy, enthalpy, Helmholtz free energy, and Gibbs free energy. Internal energy is the energy dissociated with the movement of molecule. Enthalpy is the total heat content of the system. Helmholtz free energy is the useful work that can be obtained from the system, and Gibbs free energy is the maximum reversible work that can be obtained from the system. So we go through the differences, which the first part is meaning. For Helmholtz free energy is the useful work that obtained from a particular system. And for Gibbs free energy is the maximum reversible work that obtained from a particular system. The function of Helmholtz is to create a system at constant temperature and volume. The function of Gibbs is to create a system at constant pressure and temperature. The application of Helmholtz is lesser because the Helmholtz free energy is not much used as it considered a constant volume condition. For Gibbs free energy, the application is more because the Gibbs free energy is often used since it is considered a constant pressure condition. Next, we will go to the equation of Gibbs energy. So G equal to U minus TS plus PV. So G is the Gibbs energy, U is the internal energy, T is the absolute temperature of the system, S is the entropy, P equal to pressure, absolute pressure of the system, and V is the volume of the system. But as we know that the enthalpy of the system equal to the internal energy of the system plus the product of pressure and volume, then the above question can be modified as below. So delta G equal to delta H minus T delta S. So if delta G is negative, that means that reaction is spontaneous. Delta G indicates that enthalpy volume is negative. That means energy is released to the surrounding. So when this happens, it's called an exothermic reaction. A positive delta Gibbs indicate that a positive delta H, which endothermic reaction. So next we will go to the equation for Helmholtz free energy, which is A equal to U minus TS. So for spontaneous, delta A is negative. Therefore, when a chemical reaction in a system is considered, the change in the energy that is at constant temperature and volume should be negative value in order for it to be spontaneous. To conclude, Gibbs free energy and Helmholtz free energy are two thermodynamic terms used in describing the behavior of a system thermodynamically. Both these terms include the internal energy of the system. The main difference between Gibbs and Helmholtz free energy is that Gibbs free energy is defined under constant pressure, while Helmholtz free energy is defined under constant volume. Before we end our presentation, let's see the video that we create using Powtoon to summarize the information about Helmholtz free energy. Let's go. All from our group. If you guys have any question regarding this topic, do drop below. Thank you for listening and have a nice day.